We go through our life day by day without really understanding why some things work the way they do. The reasons for why parts of nature do what they do and act the way they act can all be simplified by getting a better understanding of physics. Physics is literally all around us. Unfortunately, though, most of us don't even realize it. When you throw a ball or stop a vehicle, or even just walk from one point to another, physics explains how these things work. Physics is everywhere in this world, and we use it every single day. Physics may sound confusing, but after a little more understanding, the world will seem to make a little more sense. Three of the most important things that need to be understood before anything else are Newton's three laws of motion. These laws are very popular and very important. Newton's first law, also called the law of inertia, states that any object at rest will remain at rest unless acted on by an unbalanced force. And any object in motion will continue in the same direction at the same speed unless acted on by an unbalanced force. Many people who don't quite understand physics might try to argue with this statement because of the fact that a ball being rolled along the floor will slow down and stop eventually. But you must keep in mind that gravity is a force that pulls at about 9.8 meters per second. Gravity is a cause of a ball slowing down on a level ground, as well as wind resistance. Newton's second law of motion is actually known by everyone, whether we think we know it or not. The second law states that acceleration is produced when a force acts on a mass. The greater the mass, the greater the amount of force needed to move the object. The reason we all know this law already is because we all know it is much easier to push a shopping cart, which has a small mass, than a car, which has a large mass. Newton's third and final law of motion states that for every action, there is an opposite and equal reaction. This law can be a little more difficult to explain, but an example could be a rocket. When the rocket is launched, the force of the engines pushing down at the ground causes the opposite and equal reaction of the rocket being pushed up into the air. After understanding these three laws, physics can become a little more understandable. One branch of physics includes motion and the science of motion. This branch is also known as mechanics. Mechanics is divided into two different parts. The first part is called kinematics, and the second part is called dynamics. Kinematics is a description of motion, except without examining forces that cause the motion. Kinematics is either in one-dimensional or two-dimensional. One-dimensional kinematics is motion in a straight line. Two-dimensional kinematics is motion in a parabolic path. The second part of mechanics is dynamics. Dynamics is similar to kinematics, except that it also involves the forces that cause motion. Dynamics basically states that there is never any still moment, and everything is always moving. Motion, which is the main topic when thinking about the mechanics of physics, is something that occurs to everyone every day of their lives. This is taken for granted in everyday life, but with an understanding of physics, you can see the world with a whole new perspective. Understanding the mechanics of physics is necessary to understanding physics as a whole. Another branch of physics is the concept of momentum. Momentum is a concept that was introduced to science by the famous Isaac Newton. Momentum is more easily described as the product of mass and velocity. Every object has some sort of momentum. The heavier the object, or the faster the object is moving, the higher the momentum. When an object slows down or speeds up, its momentum will also decrease or increase. This change in momentum is called impulse. The only time there's a change in momentum is when the object changes mass or velocity. Momentum is otherwise always conserved. For example, when two objects collide, the momentum is always conserved between the two objects. There are also two kinds of collisions, elastic collisions and inelastic collisions. An elastic collision is when the two objects bounce off of each other. An example of this would be when a bowling ball hits a pin. The momentum is being conserved by transferring from the bowling ball into the pin. An inelastic collision is when the two objects stick together. An example of this would be if two cars are in an accident and get stuck together in the process. This momentum is conserved in this collision by spreading throughout two vehicles, which can cause more damage depending on the amount of momentum being spread. Momentum in collisions are everywhere in the world as well. Whether it be making a tackle on the football field, hitting a baseball with a bat, or even something as small as atoms and molecules bumping into each other. Heat is also a popular branch of physics. Heat is not what you might think it is. It is generally misunderstood and misused by many people. Heat is a way for energy to be transferred from one object to another. As the energy is transferred into another object, its internal energy rises, which then causes the temperature to rise as well. This is where we get the common misconception of heat being only temperature. Thermodynamics is the study of the patterns of energy change, which is basically saying the change of temperature. This type of physics is associated with heat and deals with energy conversions. Something that can be learned in thermodynamical physics is that there really is no such thing as cold. As crazy as this sounds, cold is just an easier way of describing the absence of heat. Another misled word is darkness. Darkness is similar to the word cold. Darkness is just an easier way to describe the absence of light. Light is a very important branch of physics because without it, we could not see, the plants would not grow, and we would not be able to live whatsoever. The source of light is simply accelerating electrons. An interesting fact about these waves are that they are non-mechanical, meaning that they can travel through anything, even a vacuum, which has no air. This is why light can still be seen in space, while mechanical waves, such as sound, cannot travel through a vacuum. I can admit that physics is a difficult course to fully understand. Although I've been involved in it for a full year of high school now, there are still many questions that could be answered. After starting the course of physics, looking at the world is so much more intriguing. It may sound crazy, but understanding physics gives the world a whole new look. It also makes nature and everything that is happening on Earth and in space a whole new level of appreciation.